of PG and Research Department of Chemistry, Kadamam Planters Association College, Bodinayakanu. In group theory, we are going to see about group and group multiplication table. A group is a collection of symmetry elements which are interrelated according to certain rules. Group may be either finite or infinite, that is, they may contain a limited or an unlimited number of elements. The symmetric groups are mostly finite. The number of elements in a finite group is called its order, and the conventional symbol for the order is H. A group in which all elements commute is called an abelian group. Here we have given the properties of group. The first property is two elements of a group combine to give the third element of a particular group. And the second one is an element combines with itself to form another element of the group. A third property is every element, that is every group, consists of one element which commute with all the elements and leaves them unchanged. The element is known as the identity element E. The fourth property is every element of the group obeys the associative law of combination. If A, B and C are three elements of the group, A into B into C is equal to A into B into C. The fifth one is every element has an inverse or reciprocal which is also an element of group. The element and the inverse combine to give the identity element. And then we know that addition or multiplication or a symmetry operation can be the combination process of elements of a particular group. In this, the set of numbers between minus infinity and plus infinity form a group by the multiplication process. 0 is not included as an element of a group for multiplication process, which leads to the formation of a group. Here we have given the example. These numbers satisfy the rules of the group as follows. When we multiply 2 with 4, it will give the third element 8 by rule 1. 2 multiplied with 2, there is an element combines with itself to form another element by rule 2. 2 when multiplied with 1, that is an identity element which leaves them unchanged, leads to the formation of 2 by rule 3. And this is for rule 4. When 2 is multiplied with 4 and 6, it leads to the formation of this same, that is 2 into 4 into 6, which is equal to 48 by rule 4. And this is law of association. And finally, when 2 is multiplied with its reciprocal, that is 1 by 2, leads to the formation of an identity element by rule 5. Here we have listed the types of group. There are 5 types: finite group, infinite group, abelian group, non-abelian group and cyclic group. Finite group is defined as the group which containing a finite or limited number of elements is called as finite group. The symmetric groups with which we shall be concerned are mostly finite. The number of elements in a finite group is called its order, and it is represented as H. In a point group, order is the number of symmetry operations possible. Thus, if we consider C2V point group, here the order is 4. For C3V point group, the order is 6. Infinite group is defined as a group containing infinite or unlimited number of elements, and the linear molecules belongs to this infinite group. Abelian group, a group in which all the elements commute, is called an abelian group. The two elements A and B commute if AB is equal to BA. The set of numbers between minus infinity and plus infinity form an abelian group under the multiplication process, and the set of symmetry operations of water molecule represents an abelian group since they obey commutative law. And then non-abelian group, a group is said to be non-abelian if all the elements do not commute with one another. The symmetry operations of the ammonia molecule provide an example of non-abelian group. the elements of a group, that is E, C31, C32, sigma V dash and sigma V double dash do not obey the commutative law. Cyclic group. A group is said to be cyclic if all the elements of a group can be generated from one element, that is here all the elements are generated from A square, A cube and so on up to AN form the elements of a cyclic group with A. Here N refers to the total number of elements and called the order of the group. Hydrogen peroxide is an example of molecule which possesses symmetry operations corresponding to cyclic group. Group multiplication table. We have listed all the elements of a group in a table that is known as group multiplication table. This table reveals the different relation between the elements of a particular group. A multiplication table consists of m rows and n columns. Each column is labeled with the group element and so each row. The entry in the table under a given column and along a given row is the product of the elements which head that column and that row. Thus, at the intersection of column labeled by X and the row labeled by Y, we find the element which is the product XY. An important theorem about group multiplication table is rearrangement theorem. According to this theorem, each row and each column in the group multiplication table listed each of the group elements once and only once. From this, it follows that no two rows may be identical, nor any two columns may be identical. And thus, each row and each column is rearranged, listed elements of a particular group. Here we have given the group multiplication table for water molecule. We have headed the row and column with the symmetry elements of water molecule E, C2, sigma V and sigma V dash. Here also the column was listed as symmetry elements of particular water molecule, that is E, C2, sigma V and sigma V dash. When E is multiplied with E, it leads to the formation of E. When E is multiplied with C, it leads to C2. And E is multiplied with sigma V and it leads to sigma V. E is multiplied with sigma V dash and it leads to sigma V dash. Here, likewise, each element was multiplied and formed a group multiplication table. As we stated already, it follows no two rows may be identical nor two columns may be identical. Here we cannot see the rows and columns which are identical in a water molecule. Likewise, in ammonia, which belongs to C3V point group, we have summarized the symmetry elements with their group multiplication table here. Here also no rows and no columns with the same identical formulation. Thank you.